So we're continuing on with our explanation of how we're going to do this testing of hypothesis. I hope it's not going to be overwhelming. It has the potential to be a little overwhelming at first, just because there's a lot of new terms being thrown out there. But I can promise you that it's a very fluid type of process once you allow it to be. And so these things that we're asking to do, this 6-step process, there's a lot of interconnected pieces to it, and I think it will go better than you might initially feel it's going to go. And you'll see that as we get into 8.2 and actually work a full problem, just how fluid all of these steps are. But it's important that we understand the definitions and the process that's going through. So if you remember, the first 2 steps are to write the claim in symbols and then identify the null and alternate hypothesis. If we're going to be able to do that, we need to know what the null hypothesis is. The null hypothesis is a statement that the value of a population parameter is equal to some claimed value. So I put equal in all caps. I bolded it and underlined it because the way our book works, and most of them do, the null hypothesis is a flat out equal to statement. And we're very focused on that null hypothesis. There's a reason why they want us to identify it. The alternative hypothesis is a statement that the parameter has a value that somehow differs from the null. So we want it to be different from the null. Well, what's the null? That it's flat out equal to that claimed value. So we want it to be different than that. For the method of this book, the symbolic form of the alternative hypothesis must use one of the following symbols. And so the symbols are the less than symbol, and I'll put it in English right over here, less than, the greater than symbol, or the not equal to. So your alternate hypothesis will only include those. So the alternate hypothesis, let me just write that out here. And they call it the alternative hypothesis. So I'll try to use that language as well. That has a symbol h sub 1 in our book. So h sub 1 is the alternative hypothesis, and it's either less than, greater than, or not equal to. It won't be any different from that. The other thing that was said is that the null hypothesis, and it has a symbol h sub 0. So right, null is 0 in some languages. So h sub 0 is the null hypothesis. The null hypothesis has one symbol, and that's the equal to. So we'll put this to practice. So we want to have a kind of a working knowledge of these definitions. So let's go look at an example. I grabbed these examples from problems in 8.2 or 8.3. I just grabbed a claim statement out of them, because the first thing you're going to do when you read a problem from chapter 8 is to go see what they're claiming. What's awesome about 8 is that's the only thing that's happening. We're just making claims. So we're going to read a problem, see what the claim is, and we're going to do step 1 and step 2. So step 1, I'll remind you of it. Write the claim in symbols. So the claim in symbols would be, I would really recommend writing the word claim. Claim. We claim that polygraph results are correct less than 80% of the time. So notice they're making a claim about the proportion or the percentage of time they're successful. So we're making a claim that if you looked at every polygraph result and looked at the percentage of correct ones, that would be represented by P. We think that that is less than 0.80. So the next 2 things are to identify the null hypothesis. Actually, let me sneak in here and make sure that we're connected back to a previous page. Step 2, identify the null hypothesis. Hopefully you're okay with me starting to use h sub 0. And the alternative hypothesis, h1. No problem. What's h0? The h0 is p is flat out equal to 0.80, right? What's h0 always? Let me come back to my definition. The null hypothesis is a statement that has the value of the population parameter equal to some claimed value. We're going to set it flat out equal to 0.80. What we're hoping to do ultimately is disprove that, because we want to show that we're less than 80%. So we're going to show that it can't be 80%. And then what's H1? H1 will be either, right, the less than symbol, greater than symbol, or not equal to. Typically, it's your claim. And so our claim definitely has one of those symbols. So that is our alternative hypothesis. Our alternative hypothesis is typically the claim. Doesn't have to be. You'll see an example a little bit later on where it's not. But I looked through the book and it's typically the claim itself. So what's the next one? This is coming from an 8.3 setting. Test the claim that the mean body temperature is different than the commonly believed 96.8. So claim. Right? I claim that, that the mean body temperature, I used the wrong symbol. I claim that the mean body temperature, that's a claim about the mean, is different than 98.6. So if it's different, I'm not claiming that it's above it or below it. I'm just claiming it's not that. And, I have the wrong numbers written there for what I wrote down. I wrote down, when I typed it out, 96.8, so I'll keep that alive. So I'm going to claim that it's different than 96.8. Well, what's my null hypothesis? No real thought there. The null hypothesis is that it's flat out equal to 96.8. And what's the alternative? The alternative is the claim if it can be, and it can be. Not equal to is one of the allowed symbols for the alternative hypothesis. So that's it. That's the claim, the null hypothesis, and the alternate hypothesis. We're done with steps 1 and 2 in that process. Example number 3. Test the claim that a majority are smoking after 1 year of treatment. This is coming from 8.2. Here's my claim. I claim that a majority of people are doing something. That might stump some individuals. It shouldn't, because there's at least 2 examples within the homework where they use this terminology. But if you're going to claim the majority of some people are doing it, you're claiming that more than 50% are doing it. That's the only way you get a majority, is if it's more than 50%. What's our null hypothesis? No problem. That's just the equal to sign with the same number. And what's the alternate? It is the claim. And we're finished with those steps 1 and 2. Last example, also coming from the 8.2 area. What's our claim? Our claim is that 51% are boys. Well, that sounds like it's flat out equal to 51%. So notice when I write my percents, I put them as their real number equivalents in the claim. The null hypothesis. Well, the null hypothesis is the exact same thing. The null hypothesis and the claim agreed. So because that's where it really gets its name for an alternative hypothesis, it's for these times where the null and the claim agree. And so what's our alternative hypothesis? That is not equal to 0.512. Right? It can't be the claim, because the claim has a symbol that we're not allowed to have. Our H1 can only have the symbols less than, greater than, or not equal to. So when I can't use it, I use the opposite of what's there. So if I look at the claim, I can't just write the claim like I could in the previous one. Here my claim was greater than. That's okay for me to use, and so I did it. Here my claim is not equal to. That's okay for me to use for the alternative, so I did it. Here my claim is less than. That's okay for me to use. This is the first time where it's not okay for me to use that. So what do? I do the opposite. What's the opposite of equal to? Not equal to. And that quickly we can get through those different claims. So that's an introduction to find the null hypothesis and alternate hypothesis. Again, the wonderful thing is you get to practice this in every single 8.2 and 8.3 problem.